Hello and welcome to English for Engineers. In this short introduction video, I want to show you what this course is about. So let's get started. What are the contents of this course? This course contains several videos which are all around about 10 minutes. They are covering various topics of engineering science. For example, there's one about physics, one about mechanics, and several about machines in a metal workshop. If you buy this course, you will get free access to all videos, to the vocabulary lists, and to quizzes. Who is the audience, in my opinion? Well, I think that this course suits all people who want to expand their technical vocabulary. I also think that it suits employees from companies who work internationally or employees who need to visit a subsidiary or a production site in an English-speaking country. I would also recommend this course for students who want to prepare themselves for an exchange year in an English-speaking country. But in general, I think that this course could help engineers from all areas, from mechanical engineering, about electrical engineering, to civil engineering, to material engineering, and many more. What is the goal of this course? We want to help you to build up your specific vocabulary for working as an engineer in an English-speaking country. A nice side effect is a short repetition of some technical basics, since the transmission of knowledge will take place with the help of science basics, which are relevant for most areas of engineering. So, who am I? My name is Sarah. I'm 29 years old. I'm a trained car mechatronic. I've also received my technician's degrees for car technology and electromobility. I've worked as an assistant in research and development for diesel engines, and currently I am absolving the teacher's training program at the RWTH Aachen in Germany. My subject in school will be engineering and English. So for now, I want to thank you for your attention, and I really hope to see you soon in the course. Bye! Hello and welcome to English for Engineers. This session deals with the math basics, so let's get started. First up, we will talk about some basic math operations. First in line is addition. If we want to add 5 to 7, we use it with the help of the operational plus. The next sign we take into consideration is the equals. We can say that 12 is the sum of 5 plus 7. The entire term is called an equation. We can also say that 12 is the solution to the equation of 5 plus 7. Next in line is subtraction. Here we deal with the operator minus. Since 5 is a smaller number than 7, we have a negative 2. We can also say that the minus 2 is the difference between 5 and 7. Our third basic math operation today is multiplication. The operational sign here can be told by two ways. We can say 5 times 7, but we can also say 5 multiplied by 7. $35 is our product and therefore also the solution to this short equation. Our last basic math operation is the division. Here get things a bit more complicated because there are several ways to say that you want to divide something. In the US, you say 5/7. In the UK, you say 5/7. But in general, you can always say 5 divided by 7. If you write something like this, you can also refer to it as a fraction. Since 5 divided by 7 does not give us a complete number, you can say, we have to work with an equals about. The solution to 5 divided by 7 is a decimal number. Depending on where you are, you can say 0.71 or 0,71. Now we head on to more advanced math operations. First up, power. So in the first line we have 5 squared. The next line is 5 cubed. The third line is general. Here we can say 5 to the nth power, but we can also say 5 to the power of n. If we have a look at our term number 4, we can say 5 to the power of 7, or 5 to the 7th power. Now we want to apply all our new knowledge. I will give you a little hint. These thingies are called brackets. I will pause this video for a moment, and you should so too, to write down your suggestion of the solution or how you would read this equation out loud. I hope you have at least a guess. So let's have a look at how I would read it out. I would start with a plus b in brackets squared equals a squared plus 2 times a times b plus b squared. Now head on to the integral. So if we have a primitive or an antiderivative function, we deal with the capital F. If we derivate it, we will come to the function in a way most of us know it the best. If we derivate it even further, we come to this. The integral sign is this one. And all of you most probably know that we also can work with integrals within limits. Here we have the upper limit, and down here the lower limit. Therefore, we can say it is the integral in the limits of a to b. Here we have another formula you can try to read out loud or write down how you would read it out loud. I will pause, you should pause, and then we talk about the solution. I would suggest that it is best to say L equals the integral dx1 equals a divided by h. Now we come to the roots. First up, we have a very simple root. Next up, we have a square root, which is indicated by the 2. Third is the cubic root. But in advanced math, we often have to deal with roots with different degrees. And then we say that this root has a degree. So we can say this is a root of the nth degree. If we want to operate with it, we extract a root. So in the last example, we extract the root of the 5th degree. Here we have another example where you can try to apply your knowledge. This formula is used to get to the 0 points of a parable. I will pause, you should pause and write down how you would say it out loud. I would suggest x1 and 2 equal negative p divided by 2, you can also say p halved, plus minus the extracted root from p halved in brackets n squared minus q. Now we head on to our last big chunk of information, trigonometry. All trigonometric functions deal with rectangular triangles, and most of them you already know. The sine, the cosine, the tangent, cotangent, the arctangent, and as I already said, they are based on right-angled triangles, like this one. In all those triangles we find a hypotenuse, and we have to keep in mind which corner we want to analyze. So if we want to have a look at this corner, the adjacent side would be here, and the opposite side is here. I hope most of you know that coming from this, the sine of alpha equals the opposite side divided by the hypotenuse. Next up is a new example, a Pythagorean theorem. Pause your video and write down how you would say it out loud. I would start with sine of x squared plus cosine of x squared equals 1. Now it's your turn. Practice. Pause the video and write down how you would say it. I would suggest a minus b in brackets squared equals a squared minus 2 times a times b plus b squared. Second practice example. Pause the video and write it down yourself. I would suggest a to the power of r divided by a to the power of s equals a to the power of r minus s. Third practice example. Pause the video, write it down yourself. I would say something like x equals the third root over a to the 4th power, or the power of 4, times b divided by c. Our last practice example. Pause the video and write it down. I would say something like jp equals the integral in the limits of s over x2 squared plus x3 squared in brackets times dA. This is the end of our first session. I want to thank you for your attention and I hope to see you next session. Have a look at the additional material like the vocabulary list and make sure you take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with the physics basics. Let's get started. First up, we will talk about some general science terms. Physics is the science of matter and energy and their interactions. A principle is a basic generalization that is accepted as true. A method is a systematic way of doing something. If something is rational, it is consistent with, or it is based on, or it uses reason. Evidence is knowledge on which to base belief. A phenomenon is any state or process known through the senses. If we interpret something, we make sense of it or reassign a meaning to it. If we hypothesize, we believe especially on uncertain or tentative grounds, so we don't know whether our claim will be true or not, but we hypothesize and we use it anyways. Here we see some prefixes for measurement units. You should keep an eye open to use the correct wording. So in Germany, for example, we often have struggle to distinguish billion, trillion and million from one another, because in German there are other terms for it which sound familiar but they are not the same. So read out this table and get familiar with it. Now we will talk about non-metric units. First up, some length measurements. 1 inch is 2.54 centimeters. 1 foot are 12 inch and therefore 30.48 centimeters. 1 yard are 3 foot and therefore 91.44 centimeters. And lastly, 1 mile are 1,760 yards and therefore 1,609.344 meters. Now we will have a short look at some volumetric units. So 1 barrel in the UK counts for 35 gallons, which is around about 160 liters. But 1 US barrel is 42 gallons and therefore pretty exactly also around about 160 liters, but the gallons differ from the UK to the US. Lastly, the pound. 1 pound is 16 ounces and therefore 455.59 grams. Now we will talk about some general concepts. First one is friction. Friction is the resistance when a body is moved in contact with another. So if you want to move your table through your room, for example, there's friction between the legs and the ground. Force is the strength or energy exerted or brought to bear because of motion or change. So you have to use force to move your table. And Newton is the measuring unit you use. So 1 Newton is the force imparting acceleration of 1 meter per second squared to 1 kilogram. Work is the force multiplied by distance moved. Gravity is the force that attracts objects towards one another, especially the force that makes things fall to the ground. And lastly, pressure. Pressure is force divided by area. Now we will talk about some temperatures. Thermodynamics are the science of the relationship between heat, work, temperature and energy. Thermal energy is the integral energy present in a system in a state of thermodynamic equilibrium by virtue of its temperature. Temperatures are measured in Kelvin, degrees Celsius, or degree Fahrenheit. Since Fahrenheit and Celsius aren't to be compared 1-to-1, there are some differences. So 0 degree Fahrenheit are minus 70.8 Celsius, but 0 Celsius are round about 32 degree Fahrenheit. If you are interested in this, have a look at the table or research it in more depth. Kinetic energy. Motion is the act of changing location from one place to another. Velocity is the distance traveled per unit time in one direction. So, for example, kilometer per hour or mile per hour. Distance is the property created by the space between two objects. Since we all know we can measure it in meter, kilometer, inches or miles. Acceleration is an increase in rate of change. And we can measure it, for example, in meters per second squared. Deceleration is a decrease in rate of change. We can measure it exactly the same way as acceleration, but it often has a negative before it. Lastly, speed is a rate at which something happens. So we can have, for example, speed of light or the speed of sound. Let's talk about acoustics. Acoustics are the study of the physical properties of sound. Noise can be any sound. And interference is the act of hindering or obstructing or impeding a wave. Pitch is the high or low quality of a sound. Resonance is the characteristic of having a loud and deep sound. A reflection is the phenomenon of a wave being thrown back from a surface. And lastly, decibel are a unit of sound intensity. Let's talk about waves a bit more. So, a wave is a movement up and down or back and forth. Wavelength is the spatial period of a periodic wave, the distance over which the wave's shape repeats. Frequency is the number of occurrences within a given time period. An amplitude is the greatness of magnitude. Hertz is a measurement unit. Let's apply some terms. So here we see a wave, and we will start with some basic terminology. Here we have an axis. Here we have as well an axis. I've started. Now I will pause for a minute, and then you can apply the terms you kept in mind. So I hope all of you identified this as a wave, and most probably it will be a sine wave. We can see a positive peak and a negative peak. We have here our amplitude. And we can also measure our wavelengths. Next up, we want to talk about optics. Optics is the branch of physics that studies the physical properties of light. A prism is a polyhedron with two congruent and parallel faces. A refraction is the change in direction of a propagating wave. If something absorbs, it takes something in. For example, waves of light. A concave building is something which is curved inward. So, for example, like this. If something is curved or bulging outward, we say it is convex. So, if we have this, it is convex. If we have a convergence, things are getting closer. So we can say that this line and this line, they are converging. If something is diagonal, I think most of you will already know it, because this means it is going from one corner to another. And lastly, diffuse means something is spread out or not concentrated in one place. Let's talk about chemistry. Chemistry is the scientific study of the properties and behavior of matter. Organic is a chemical compound which is having a carbon basic. A compound is a substance formed by chemical union of two or more elements. So, for example, water is a compound because it is H2O. An element is a substance that cannot be separated into simpler substances. So, for example, simply the O. A formula is a symbolic representation of the composition of a compound. So we could say 2H plus 1O become 2H2O. Let's talk about atoms. They are the smallest component of an element. We have the nucleus, which is the dense center of an atom. We have the protons. They are a particle with positive charge. The neutrons. They are particles with zero charge. The electrons, which are particles with negative charge. Valence electrons, which are special electrons since they are in the outer shell of an atom which can combine with other atoms to form molecules. And a molecule is a group of two or more atoms held together by attractive forces. So, for again, as an example, H2O. And isotopes are two or more types of an atom that have the same atomic number and that differ in the nuclear numbers due to different numbers of neutrons in the nuclei. So each of the nuclei of the different isotopes weigh different, and therefore they are isotopes and not the same element. So pause the video and apply the atom terms to this little picture. Let's start in the middle of this thing. Here we have the nucleus. It consists, as you maybe remember, of protons and neutrons. If we move wider, we have the first shell. It got electrons. And the most outer shell consists of valence electrons. That's it for this session. Thank you for your attention and see you next session. Make sure to have a look at the additional material like the vocabulary list and take our little quiz. Bye! Hello and welcome to English for Engineers. Today's session will deal with mechanics, so let's get started. What is mechanics? Mechanics is the study of the relationships between force, matter and motion among physical objects. So mechanics looks at how objects in our world are interacting, how their matter, so the things they consist of, the force, so the energy or the energy, and also the movement of these objects, how they are interacting and what happens. Pneumatics is the branch of mechanics that deals with the mechanical properties of gases. So you see pneumatics, or at least you hear it, in your everyday life. Pneumatics is important for braking systems in buses or trucks, and even the lifting and lowering of buses is often done with pneumatics. That's why they sometimes make this psht noise, and this is when they are letting air flowing out of their valves. Next up is hydraulics. This is the study of the mechanics of fluids. So there are also hydraulics in your everyday life. For example, the water in your pipes in your kitchen, but also the braking systems of cars or motorcycles. Dynamics is the mechanics concerned with forces that cause motions of bodies. Dynamics has the very famous example of a ball running down a hill, for example. Statics deals with the force acting on a stationary body, which is the balance of forces to keep the body in equilibrium. And equilibrium is a state of balance, simply as that. Statics deal with all things which are simply not moving, and if they are not moving, they are in equilibrium. Kinematics deals with the calculation of the possible movements of the body using different equations, and kinetics explains or foresees the motion of a body in various circumstances using Newtonian laws. So these two are working close together, and they are applied, for example, to construct loopings and water slides. Now, let's talk about some general terms. First up, energy. Energy is the capacity of a physical system to do work. Potential energy is energy stored by a body or system by virtue of its position. So if we are having, for example, this little tube and it is positioned down here, it got a lower potential energy as if I would lift it above my head. That's all what potential energy says. Kinetic energy, the mechanical energy that a body has by virtue of its motion. So if I have this little tube here and now it would fall down, during the fall its kinetic energy would be higher than when it is standing still. Power is the energy transferred by time, and work causes a change of energy, and joule is a unit of electrical energy, but it can also be transformed into other units. Talking about units, let's have a short look at these. Power is written with a capital P, and its unit is the watt. But 1 watt is also 1 joule per second. And we can also say it's 1 volt multiplied by amperage. But we can also say it equals 1 kilogram times meter squared divided by a cubic second. So here we see that all these units are somehow linked to one another. So it's important to have them in mind, and also to check your calculations, for example, to have a look whether these units make sense in your equation. So after this little transformation of units, let's head on. Now we will talk about some simple machine parts you will come across when you are studying and you often have to do some basic calculations. First up, the rope. A rope is a strong, thick string made of twisted threads. like this one. So here we have our rope. And as you can see, it is on a hook. Next up, the rod. A rod is a long, thin pole made of wood or metal, like this one. They are often used for framework constructions. So the area of a rod is something round. This is important because next up, a bar is also a long, thin, straight piece of metal or wood, but as you can see in the picture, they have an area which is most often like this, or it could also be tetragonal or hexagonal, and they are used to make gates, for example. A beam is a long, thick piece of wood, metal or concrete, especially used to support weight in a building or other structures. Here you see it used as parts of a framework construction in a house. So let's talk a little further about simple parts of machines. A bearing is a machine element that constrains relative motion to only the desired motion and reduces friction between moving parts. We can have a fixed bearing or a floating bearing. Here we have a ball bearing, and it is often used as a fixed bearing since those little balls are moving inside this little notch. I hope you have an idea what I'm talking about. And because they cannot move from one side to another, it is fixed, and therefore it's a fixed bearing. A centroid, or the center of gravity. I think most of you will already know it. So if I have an object, it has a centroid or a center of gravity. And if we have a triangle like this one, we will find it quite easily. And now you see I'm balancing it on my finger, and it's still somehow in equilibrium, so it doesn't move. Now we will talk about mechanical loads. First up, the stress. This is a force that produces strain on a physical body. And strain is the deformation of a body under the action of applied forces. So if I'm taking this triangle and I'm bending it, I apply stress and it ends in a strain of the triangle. Velocity is the distance traveled per unit time in one direction. Well, we all know velocity. I think we know it best from cars or buses or bicycles. Speed is a rate at which something happens. So, of course, we all know speed from cars, bicycles, and trains. But speed is also how fast or slow I am bending something. So even there we can talk about speed. More mechanical loads are, for example, the torque, which is a twisting force. So if I now here have something with a round area, I can twist it, but I can also do it with something cubic, but I just have this round thing. Friction is the resistance when a body is moved in contact with others. So we all know it from, for example, a table or a chair we want to move across a carpet, for example, then they have friction between each other. But if we have a look at my thingy here and I tear it apart, it also experiences friction between the rubber and the tube. A distortion is a change of the original or natural shape of something. So for example, if you have a tennis ball, and you squeeze it, then it's a distortion. The moment load is a turning force produced by an object acting at a distance. Wow, this sounds complicated, but it's simply something with a bearing. So here we have a fixed bearing. And then we have a force, which would be this hand. And it applies some strength, and now we have a distance and we have an acting force, and this causes a momentum, a moment load. Be aware, a moment load is not the same as momentum. So I've done something wrong. Because the momentum is a product of a body's mass and its velocity. So like you can see here, if I have, for example, a tennis ball on a rope and I letting it fly in a circular motion, it has a certain momentum. And if I would let go of the string, the ball would fly away. As you can also see in this little drawing here, the ball is here and it would be attached to a string which connects it to the middle of the circle, and it always has this velocity. And if I let it go, it is flying in a straight motion because of its momentum. So tension is a stress that produces an elongation of a physical body, which means something gets longer. So again, if I take this tube and I apply some tension, it got longer. And the counter movement, you can say, is the pressure. The act of putting pressure of something so it becomes shorter. For example, if I take this and I put it back together. So let's talk about some applied mechanical loads. Rods and bars, so the thin and long construction pieces, take only tension and pressure. So here we have a construction, a framework construction, and per definition this can only take a force like this or a force like this. Oh, but beams can take all kind of forces. So here we have a beam with a floating bearing and a fixed bearing. And it can take, for example, a force applying here, which would be a pressure, for example. But it could also take a force which applies some tension here. And this force here will cause a momentum in this bearing. So that's the end for this session. Thank you for your attention and hope to see you next session. Have a look at the additional material, like the vocabulary list, and make sure to take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with statistics and charts, so let's get started. We will start with some general terms. Statistics is a branch of mathematics concerned with quantitative data. Data is a collection of facts from which conclusions may be drawn. Qualitative means involving distinguishing attributes, whilst quantitative means something is expressible as an amount that can be measured. And an axis is a line on which the scale of measurement is marked. Most of you most probably know the x-axis and the y-axis. What elements are part of a graph? So the graph itself is defined as a representation of a function as the set of pairs, so the x value in combination with the x from f value or the y value. An intersection is the point in which graphs meet. So two graphs can cross at an intersection, or maybe all graphs you want to plot cross in one intersection. A 0 point is the value at which a graph crosses an axis, so it can cross the x-axis or the y-axis or any else axis. The maximum is the highest point of a graph, whilst the minimum is the lowest point of a graph. A graph can be falling, which means the values following each other's decrease, or it can be rising, which means the values following each other grow. If a graph is linear, one thing changes at the same rate as another, so that the relationship between them does not change. And it often has the form of a straight line and it does not create a curve. So let's apply some terms we just learned. I will pause for a moment so you can pause the video and you can write down the words you remember. I want to start with the axis. So here we see our y-axis and here our x-axis. We also spot an intersection. I would say that the graph from here to here is linear. We can also spot some 0 points, so we have them here and here. We can also spot some rising and some falling. So next up are variables and sorting. We often have an independent variable, which is a value that does not depend on changes in other values. And the dependent variable, a quantity whose value depends on another quantity. So often the dependent variable depends on the independent one. If we have two variables, something is called bivariate. A group is any number of entities which are considered as a unit. So if they are arranged into groups, you can say that they are grouped. We can also have classes, and a class arranges or orders by categories. If something is categorical, it is relating to or it is included in a class or in classes. And we can also categorize, which means we place something into or assign it to a category. Now we will start to work with numbers. First up, the range. The range is the set of values that is the output of a function. Outlier are a person or a thing or pieces of data that does not conform to a norm, which are outside of the graph, for example. Continuous means it is extending without a break or irregularity. If it is numerical, it is relating or denoting numerals, so numbers. If it is ordinal, variables have a natural ordered category. A pattern is a repeated design, a structure or an arrangement. And a peak is the most extreme possible amount of a value. We can also say it is a maximum. The spread is the distribution or the dispersion, and it has to be widely. The frequency is the number of occurrences. A percentage is a proportion in relation to a whole. The mean is approximating the statistical average or the expected value. The median is relating to the middle value of an ordered set of values. The mode is the most frequent value of a random variable. A correlation is a statistic representing how closely two variables covary. So if we are changing one, the other is changing as well. We can therefore say they are both depending on one another. An interpolation is a calculation of the value of a function between known values, whilst an extrapolation is a calculating of a value outside of the range of known values. Fluctuation is the quality of being unsteady and subject to changes. A trend line is a line on a graph indicating a statistical trend. We can therefore say that a fluctuation and a trend are somehow opposites to one another. An interval is a set containing all points between two given endpoints. A frequency distribution is a distribution of observed frequencies of occurrence of the values of a variable. A variation is an instant of change, the rate or the magnitude of change. So if we have a lot of variation, we have a wide range of data we collected with very wide range of magnitude, for example. So maybe we collected many data and we have values from 1 up to 500, then we have a lot of variation. A deviation is the difference between an observed value and an expected value. So if we expected that we will only get 500 as a measurement, but suddenly we have 5,000, this is a very huge deviation. A discrepancy is an event that departs from expectations. So it's just like a deviation, but a bit more extreme and singular. Distribution is an arrangement of values of a variable by frequency. And a normal curve is a symmetrical curve representing a normal distribution. And exactly this normal curve is also called a Gaussian bell curve. And now I want you to stop the video and apply some terms we have just learned. So, as I just said, this Gaussian bell curve is a normal distribution because it is symmetrical. So here and here we have the same amount of falling or rising. And we can also see that here are 50% of all our values, and this is the peak and also the mode. As you remember, the mode is the most frequent value. We can see that this function has a spread which starts here and ends here. Let's talk about charts. First up, we'll talk about a bar chart. This is how it looks, and they are used to display data that are grouped into nominal or ordinal categories. They compare data among different categories, and they show large data changes over time. Next up, the histogram. This is how it looks. A histogram visualizes continuous data. It represents the shape of the data's distribution, and it compares the outputs of two or more processes. Here we see that we have approximately a normal distribution again, and you see that you can show it with the help of a histogram, but you can most probably also show it with the help of a line chart, which we will talk about next. The line graph. This is how they look. They show trends. They make predictions based on data history over time. They compare two or more different variables, situations, and information over a given period of time. So we see here we have 4 different categories, and we have 3 different series, and we even have an axis with some measurement to it. A scatter plot looks like this. Here are just 3 little points, but most often there will be some more. So for example, it would look like this. so many measurement points, and then most probably also there will be a line which will indicate what is the middle of the data set and what is the trend, you can say. Scatter plots help you to find out whether there is a relationship between two variables. They predict the behavior of dependent variable based on the measure of the independent variable. So just what is said in the first point, whether two things are dependent on one another. And our next chart is the pie chart. This is how it looks. It is used to represent the composition or the growth of something. For example, if the company has grown in their capacities, in the amount of things they sold, and then you can see which goods sold best or something like this. They display nominal or ordinal categories of data, and they show percentages of proportional data. The area chart looks like this. It shows trends rather than it expresses specific values. It gives a simple comparison of the data of the trend of data sets over the period of time. And it displays the magnitude of a change. Now we will talk about box and whisker charts. This is how they look. They visualize the upper and lower quartiles, the mean, the median, deviations, and other stuff. And they are able to represent a huge set of data. They give a quick view of the dataset distribution, and they can compare data from different categories or datasets. So here we have 3 colors and therefore most probably 3 datasets. The radar chart looks like this. It represents multiple comparisons, and it can help to spot quickly which variables are scoring low or high within a dataset, and therefore they are ideal for displaying performances. So you can, for example, scan a personality of core workers like this if they do personality tests. But you can also tune an engine with the help of this or a powertrain. Now it's your turn. I hope you will remember some of the terminology I just introduced to you and you can apply them now. So here we have a box and whiskers chart. We will start with this little spot here. This is an outlier. Here we have a maximum. Here a minimum. The line in the middle is the median. And we can also spot the upper quartile and the lower quartile. Next, I want you to apply your knowledge on this graph. I want to start with a peak, which could be this one. Next up, we can also see a trend, which would be, for example, this straight line or this straight line. So the arrows are trends. We also have several intersections. Here, here, and here, and even here. Next, we can also say that we can have intervals here. So this, for example, could be an interval. We can also guess that each line is most probably an ordinal category. So they have distinguishing features, for example, dogs, cats, and rabbits. And the values which are measured are numerical. And they are now the points, for example, which can be measured with the help of the y-axis. We also have a falling graph and some rising graphs. And yeah, that's it. I want to thank you for your attention, and I hope to see you in the next session. Have a look at the additional material, like the vocabulary list, and make sure to take the quiz as well. Bye! Hello and welcome to English for Engineers. This session deals with electrical engineering, so let's get started. First up, we will have to talk about some general terms. Electric and electronic. So an electric device is working with current and some very basic components, for example a mechanical switch. A good example would be your electric heater. An electronic device is computer controlled, so it is more complex, for example like your smartphone. An electrical device, or general something electrical, is relating to or concerned with electricity. Electricity herself is a physical phenomenon that can produce light, heat, or power if it is converted into other kinds of energy. Electromagnetism is magnetism produced by an electric current. But magnetism, in general, is the attraction for iron. So here we have a magnet. And a magnet is a device that attracts iron and produces a magnetic field. So here we have our magnet. And all these little balls are most probably made of iron. And to go a bit further into detail, we also have two poles. So here is one, and here is one. And a pole is one of the two ends of a magnet where magnetism is the strongest. The magnetic field. A magnetic field is an area around a magnet or something magnetic in which it can apply a force to magnetic objects. It exists around a permanent magnet. So here we have this permanent magnet. And we can almost see the magnetic field. So for example here we have it, and we have it here, and we can also see it here. And as you remember, the field is the densest near the poles. So if you remember from the slide previous, here are the poles. The arrowheads from the magnetic fields always go from the negative pole to the positive pole. The circuit. A circuit is an electrical system providing a path for current to flow. So you need a conductor and a conductor plate, for example, so the current can flow through it. And a current is a flow of electricity through a conductor. Its unit is ampere. Voltage is the force of an electric current, and it's measured in volts. Resistance is the degree to which a device prevents the flow of electricity through it, and it is measured in ohm. Conductivity is the property of allowing heat or electricity to go through something, or the degree to which a substance allows this. So a resistor has a very low conductivity for electricity. So let's have a look at circuits in detail. We often need a power source or a power supply, And this is often a device which is plugged into a socket or which has stored power, for example, batteries, and they provide electrical energy. And we need cables. So here we have our power source, and these two lines are our cables. So let's add some components to our circuit. First up, a switch. A switch is a small device that controls and turns on or off an electric current. And a resistor is a material with a little electrical or thermal conductivity. Here we have our resistor, and here the switch. A transformer is a device that changes the voltage and current of electrical power as it moves from one circuit to another. Those lines here are the symbol for a transformer. And another symbol we have here is a motor as an electrical equipment. We can also say that a transformer is a contactless switch because it is transferring electrical energy with the help of induction. Next up is the transistor. This is a small electrical device containing a semiconductor used in televisions, radios, or something else to control or increase an electrical current. This entire thing is called a transistor. And this is a very basic electrical equipment, a light bulb. A transistor always has a collector, an emitter, and a basis. So if the collector and the basis have a flow which is huge enough, the emitter will allow some electrical energy to flow through it, and then our light bulb will also start to shine. So now we will talk about some kinds of connections. A series connection, in which electrical equipment is connected right under one another. So this one. And the parallel connection, where electrical equipment is connected parallel to one another. So if we ask ourselves, where do we have these? So a series connection is often in Christmas lights. If one is broke, there is no light shining anymore. And a parallel connection is often in batteries. If one is broke, the others will work perfectly fine. But of course, the power output will be less. Now we will have a short look at active current. We have an amplitude, which is this. We also have a frequency, which is the number of occurrences within a given time period. So here our frequency is 1, since we have just one wave. And a period is the interval to complete one cycle of a repeating phenomenon. So our period starts here and it ends here. And the crest is the top of a line of a hill, mountain, or wave. So here we also have our positive crest, and here we have a negative crest. Now we will talk about the electrical motor. The basic components of it are a stator and a rotor. So the stator is a part of a motor which does not turn, it is static, and a rotor is a part of a motor which does turn, so it rotates. And here we have a very basic drawing of a rotor. And here we have our stator. And as you most probably will know, this will go inside here, so they can work together. Windings. Copper wires are coiled up, and they are often coiled up around an iron core, and then they will conduct current. And the iron core is positioned in the middle of the windings to boost the power of the motor. So we can see here the orange color is standing for the windings, and the black color symbols the iron core. So here are the iron cores, and then we have our windings, which are coiled up around them. We can also see here a little black, so there again are our iron cores, and then those little lines are our windings. We also have here windings, but I didn't manage to draw some iron core in it because otherwise I was afraid nobody will have a vague idea what I try to tell. Next up, the carbon brushes. These brushes touch the shaft of the motor to transfer the current. The commutator changes the polarity of the rotor, and the encoder, or the position transmitter, tells the motor management system how the rotor is positioned. So all these three components are packed closely together, and most often they will sit in front or in the back of the rotor. I didn't draw them here because they look very different from every motor to other motor, and also there's no good way to say, yeah, well, it is 100% fixed that it is like this, because each and every producer of motors will do it a little bit different, so there's no point in drawing it inside this except for it gets more complicated. I want to thank you for your attention, and I hope to see you next session. Have a look at the additional material like the vocabulary list, and make sure to take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with materials, so let's get started. First up, we will have to do a little distinction between the materials. Therefore, we will have a look at the periodic table of elements, and we have to differentiate between metals, which are often used in the metallurgical industry, metalloids, which are often used in the high-tech industry, and non-metals, which are often used in the chemical industry. And where to find these within our periodic table? I've drawn some colorful frames around them, you can say. So first up, we want to talk about the metals. And here you see the blue frame I created. And within this frame, all elements are metals. Then within the green frame are all metalloids. And in the orange frame, you can see the non-metals. So how are these defined? A metal is a chemical element or an alloy that is usually a shiny solid. So it is very hard and it often has a shiny surface. Metalloids are elements intermediate in properties between metals and non-metals. So they have some characteristics of metals, but they also have some of non-metals. And a non-metal is a chemical element that lacks the characteristics of a metal. So here I have prepared for you some alloys. I think that they are bronzes. And this little picture is standing for a circuit, so most probably it is something which can stand for silicium. And here we have an air balloon filled with helium. So let's talk about metals. Minerals are a solid inorganic substance occurring in nature. and within these minerals we often can also find metals. An alloy is a mixture containing two or more metallic elements. For example, all your jewelry is most probably an alloy of several elements. A grain is the form of the crystals in a metal. So here I have drawn for you a microscopical picture of austenite, which is a special form of iron. So these huge chunks are all grains of the austenite, and typical for austenite are these two strokes within it. And a stack is an orderly pile of, for example, grains. Here I have drawn for you pearlite. And here you see that all these little cubics are the grains of the pearlite, and they are stacked. So let's talk about metals a bit further. A bronze is an alloy of copper and tin and sometimes other elements. Here you can see that this figure has most probably around about 3 different bronzes. So the hair is very dark and we have no coating in it. Then we have the face, the upper body and the arms, which are very brownish. And then we can see that the dress has this green bluish coating, and I think that the dress most probably has the most copper in it. Rust is a red or brown oxide coating on iron or steel caused by the action of oxygen and moisture. So here we see a typical iron chain, and it got a lot of rust on it. Next, we want to talk about the metallic elements you can find in the periodic table a bit more in detail. I won't be able to talk about all of them, but I want to show you some which were the most important for my studies and also for my work. First up is lithium. It is a soft silver-white univalent metallic element, and it is the lightest metal known. Next to it is beryllium, a light, strong, brittle, gray, toxic, bivalent metallic element. Underneath it is magnesium, a light silver-white, ductile, bivalent metallic element. Magnesium is often used, for example, when you have a high-speed car and their rims are made out of magnesium, or the trunks, because it is very light but still very strong. Calcium is a white metallic element that burns with a brilliant flame. Iron is a heavy, ductile, magnetic metallic element. Well, I think most of you will know iron because it's just, I think, the most famous metal of all. Nickel, a silvery white lustrous metal with a slight golden tinge. Molybdenum, it readily forms hard, stable carbides and alloys, so it is often used in steel alloys. Tungsten, also known as wolfram, it is very robust and it has the highest melting and boiling point of all metals which are known to mankind. Wolfram is often used within light bulbs. And platinum is a heavy but precious metallic element. So now we want to talk about copper. Copper is a ductile, malleable, reddish-brown, corrosion-resistant, diamagnetic metallic element. So we all know copper is very good to be used in some wires, for example, because it is good for conducting current. Next up is zinc. It's a bluish-white, lustrous metallic element. Silver, a soft, white, precious, univalent metallic element. So we know silver from jewelry, for example, just as well as gold. Gold is a yellow, malleable, ductile metallic element. And mercury, a heavy, silvery, toxic metallic element. And it is the only metal that is liquid at an ordinary temperature. We all know mercury from older times when how are they called? Temperature scales were filled with mercury. because mercury expands when it gets warm. And so these temperature scales were kind of dangerous, because if a child would drop them, they could not just be caught by the glass, but they could also be poisoned by the mercury in it. So, the last of our metallic elements. Aluminium is a silvery, ductile metallic element found primarily in bauxite. Bauxite is a mineral. Tin is a soft, faintly bluish-white, lustrous, low-melting metallic element. And as I've already told you, it is often used in bronzes. Lead is a heavy metal, soft and malleable, relatively low melting. Sorry, I've forgotten space here. Relatively low melting point, space. It is shiny gray with a hint of blue or a dull gray color when it is exposed to air. It is toxic, and it is toxic even in small amounts. Lead is often used for soldering on circuits, for example. But since it is so toxic, we try to get away from it. So there are often soldering equipments and solders which are lead-free. Now, we will talk about the nonmetals. Synthetic means that something is a compound made artificially by chemical reactions. Plastics are organic, synthetic, or processed materials. So here we see some Lego cubes made out of plastics. And last up, ceramics. They are an artifact made by clay. They are baked at a high temperature. Next up, fabric. Materials made by weaving, felting, or knitting fibers. So here we have a jute sack, for example. And a diamond is a very hard native crystalline carbon valued as a gem. And if you combine it with, for example, a silvery ring, we have a construct. Synthetic rubber is any artificial elastomer, and they have a different range of physical and chemical properties. And because of that, we can use them for tires, gaskets, or flooring, or for example, running shoes or coating of some lifting equipment. Wood is porous and has a fibrous structural tissue. It is found in stems and roots of trees and other woody plants. So, where can we find these non-metal elements? Carbon is an abundant non-metallic element in all organic compounds. So, even in diamonds, as we just have heard. Nitrogen is a common non-metal element, and it's a constituent of all living tissues. Oxygen is a colorless, odorless gas that is essential for respiration, so breathing, and producing metals. Sulfur is a tasteless, odorless, non-metallic element, and we all know it by its yellow crystals. Now we want to talk about some general characteristics of materials. They have a surface, which is the outer boundary of an artifact or a material layer. They have a texture, which is the feel of a surface or a fabric. So you can say that when you touch the surface, you can feel the texture of something. For example, if I feel the texture of my blouse, I can feel that it is weaved and it is quite soft, and I can wear it quite easily and comfy because it isn't stiff. Lustrous means something is reflecting light. So for example, like my glasses, they are reflecting light because the surface is lustrous and also very polished. Opaque means something is not transmitting or reflecting light or radiant energy. So for example, black plastics. I think that this is the best example for it. Transparent is the complete opposite. So if something is transparent, you are able to see through it and you see clearly through it. So my glasses are transparent. Liquid means a fluid matter having no fixed shape but a fixed volume. Viscosity is the resistance of a liquid to flowing. So water, for example, has a low viscosity, but oils often have a high viscosity, especially if they are used in engines or gearboxes. Fragile means something is easily broken or damaged or destroyed, for example, like glass. Hollow means something is not solid. It is having space or gaps in its cavity. For example, a football would be hollow because it has a surface made out of leather or something like this, but within it there is a lot of nothing, so it is hollow. An insulator is a material with little electrical or thermal conductivity. So, for example, ceramics. Ceramics are a very good insulator, while copper is most probably the worst insulator you could use. In conduction is the transmission of heat or electricity or sound. So this is closely bound to an insulator. So ceramics are poor for conduction because they are not transmitting any electricity. But copper is a good conductor because it is letting the current of electricity flow very easily. Porous is a material with void spaces. And if something is likely to dissolve, it will pass into solution. So salt, for example, if you put a tablespoon out of salt in a water or boiling water, for example, for noodles, then it is dissolving very easily. Malleable means something is capable of being shaped or bent. So, for example, like soft metals like copper or silver or gold. Ductile means something is capable of being shaped, bent, or drawn out. Again, soft metals. Elasticity is the tendency of a body to return to its original shape. It is resuming shape after stretching or compression. So, for example, if you have a rubber and you can just bend it and it will always come back to its shape and it doesn't really care. Toughness is the elasticity and hardness of a metal object. If something is inelastic, it is not able to resume shape after stretching or compression. For example, like ceramics. If you have, for example, this thing, you cannot, even if I squeeze very hard, I cannot bend it. But if I would squeeze even harder, then it wouldn't be able to resume its shape because it would simply break. If something is solid, it is not soft or yielding to pressure. So, for example, if you have a huge chunk of cast iron, it is very solid, so you cannot compress it any further. Stiff means it is incapable of or resistant to bending. So, for example, ceramics or glass. So you cannot bend them because they would break or do nothing. And a crack is a narrow opening. And things which are very stiff and solid tend to crack. Brittle means having little elasticity. So here we are back with stiff or solid objects. If you compress them, they can have cracks afterwards, or they can brittle, so they will fall apart to little pieces. If something is compact, it is closely and firmly united or packed together. So again, for example, forged iron. And the density is the amount per unit size. Okay, so this means if something is very compact, it has a high density. And if something has a lot of void between it, if it is very porous, it has most probably a low density. Corrosion is an erosion of chemical action. So if you have already seen, iron will have rust on it, which is the corrosion of iron. and copper or aluminium will have a bluish coating after some while. Magnetic means something has a certain attraction to magnets, or counterwise, a magnet is attracted to iron and iron is attracted to a magnet, so they interact a lot. So, I have talked a lot now. I want you to pause the video and apply some characteristics I have just told you. Okay, so first up, here we have a foam material. It has a low density because it has a lot of voids within it. It is very elastic. It is soft and porous. Then here we have paper clips. They are elastic, so you can bend them. They are magnetic, as you can see, because they stick to this magnet. They are ductile, so you can squeeze them easily. Next up, the glasses here. So the glass has a high density. It is transparent, but it is also very fragile. It is inelastic and it has a lustrous surface, so you can see that the light is reflected very easily and clearly around it. Last up are these gummy balls. So they are elastic and they are transparent. Thank you for your attention and see you next session. Have a look at the additional material like the vocabulary list and make sure to take the quizzes. Bye! Hello and welcome to English for Engineers. This session deals with working with materials, so let's get started. What are the origins of metals? Metals are often excavated in a quarry, and a quarry is a surface excavation for extracting stone or slate. A mine is a hole or a system of holes in the ground where substances are removed. So you can say that a quarry is on the surface, whilst a mine is down below, so in the earth itself, you can say. A vein is a layer of ore between layers of rock. And ore is a mineral that contains metal which is valuable enough to be mined. So if we have a look at the dark picture of the mine down here, we can see that there are some layers which are more lustrous than the rest. And within these layers run the veins. And these veins contain the ore. From crumbs to billets. A foundry is a factory where metal castings are produced, like on this picture. Melt is to reduce or to cause to be reduced from a solid to a liquid state. Slag or smelt is the scum formed by oxidation at the surface of molten metals. So the black spots here, for example, are slag. The mold is the distinctive form in which a thing is made. And if it is made with the help of a mold, it is called mold casting, like you can see on this picture. And again, we can see some slag in form of darker spots on top of it. And this spoon here is supposed to hold back huge pieces of slag. An ingot or a billet is a piece of metal cast in the shape of a block. So we put the molten metal in a mold and afterwards we will receive a billet. Blacksmithing. A forge is a furnace used to heat metal so it can be worked or melted. But if something is forged, it also means it is created by hammering. Heat is a form of energy transferred by a difference in temperature, but you can also say to heat something up. An anvil is a heavy block on which hot metals are shaped by hammering. So here we see the anvil, we see a hammer, and an object which is formed by hammering. Hammered means shaped or worked with a hammer and often showing a hammer mark, so little dots and it is quite uneven. If you pat it with a hammer, you hit it lightly, so you make a fine form. But if you smash it, you hit violently and you want to get a rough shape. Squeezing is also used in blacksmithing, but if you squeeze, you press very firmly, so you will most probably use the help of a hydraulic press. Treatments for metals. There are several heat treatments, for example, homogenizing, grain coarsening, normalizing, recrystallizing, soft annealing, or tempering, but I won't talk about these in detail because these are so complex that it would be like 1 hour of just talking me, and we won't do it in this video. Quenching is the rapid cooling of a workpiece in water, oil, polymer, air, or other fluids to obtain a certain material property. And if you quench it very rapidly, for example in water, you would reduce the elasticity, so it gets very stiff and brittle. If you temper your workpiece, you also apply a process of heat treating, but this is used to increase the toughness of iron-based alloys. So after quenching, you have a very hard and stiff material with a very low elasticity, but after tempering, it is more elastic but still very hard. To concentrate something means to make it denser, stronger, or purer. So when you would quench and temper, you can concentrate the metal more, and you can also purify it, especially when you forge it and foreign materials get burned and then they are in form of slag all around the workpiece, and then you just brush it away and then it's more pure. Joining materials permanently. Flux is a substance added to molten metals to bond with impurities. So, as I just said, when you are forging, you will add some flux, and then all the scum is collected, so it bonds, and then you can brush it away or hammer it away. A weld is a metal joint formed by softening with heat and fusing. We can forge weld or MIG or MAG weld. If we forge weld, we take 2 hot billets of metal together, and then with the applying of force they will bind. But if you would do some MIG or MAG welding, you will melt the material up to a certain point and then they will fuse with one another. But you do it with different processes, so melting with electricity or melting with gas, so with a flame. Soldering is something you do to 2 or more items which are joined by melting and putting a filler material, a so-called solder, into the joint. The filler metal having a lower melting point than the adjoining metals. So when you weld, you melt the actual material you want to combine. But when you when you do soldering, you apply a melting metal in the gap between 2 things you want to join. When you finish workpieces, you most probably want to polish it. And if you polish, you make especially a surface shine. If you have a scratch, which is a cut, a scrape, or wear away on the surface of a workpiece or of a machine part, you most probably will have to polish it again. To grind means to reduce to small pieces or particles by pounding or abrading. We will have a look at a grinder in a minute. If you tear something, you separate it or you cause to separate it abruptly, which means that if I would tear on this pencil and it suddenly rips apart, I have torn it apart. And to drill means to make a hole, especially with a pointed power or hand tool. Now we want to have a look at some machines. And a machine is a mechanical or electrical device that transmits energy. First up, the lathe. And a lathe is a machine tool for shaping a piece of rotating wood or metal. So, as you can see on this picture, this part which is holding our workpiece is rotating. And our tool isn't rotating. It is just moving to the center and away again. And you can also move it in another direction. So you can move the tool in this direction and in this, but you can also move it in this and in this direction. But you are limited to these two directions, and your workpiece does nothing but rotate. A milling machine is a machine tool in which metal that is secured to a carriage is fed against rotating cutters that shape it. So here our tool is rotating, but our tool can also move in this and this direction, whilst our material down here can be moved in this direction, or it can be moved in this direction. So this depends on the machine you're using. If you have a very modern machine, most probably the tool as well as the workpiece can move in several dimensions. So yeah, things get really complicated, but you can also produce very complicated geometries. A soldering iron is a hand tool which supplies heat to melt solder so that it can flow into the joints. And a welding device joins materials, usually metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool, causing fusion. A grinder processes materials by grinding or crushing. So we can see that this grinder is producing a lot of sparks, and these sparks are very tiny, very hard pieces of metal which are grinded away. A compressor is a mechanical device that compresses gases, and this is very important for a workshop for many reasons, because you can power many tools with the help of compressed air. A pump is a device that moves fluid or gas by pressure or suction. So here we have a very old school pump, which is controlled with the help of the muscle power of a human. But of course there are also electrical pumps. A hydraulic press is a device that is used to put weight on something in order to crush it or to make it flat. It is supported by hydraulic forces. So here we see our manometer, where we see how much pressure we apply. And this is the lever which is applying the pressure. And this specific press is used to produce wine. So now we are already at the end of this session. I want to thank you for your attention, and I hope to see you next session. Have a look at the additional material, like the vocabulary list, and make sure to take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with technical drawings, so let's get started. First up, we want to talk about the most important components. The title block. It includes the title, drawn by, approved by, name of firm or name of company, material of the workpiece, the scale, the copyright note, the part number, and depending on the company you're working in, several other informations. The notation is a comment or an instruction. It is usually added, and it often deals with surfaces or finishes. There are several scales: a magnification scale, a natural scale, or a reduction scale. So a magnification scale makes something small bigger. So 50 centimeters on a drawing is 1 centimeter in real life. So on the actual workpiece. A natural scale does not magnify nor reduce. And a reduction scale makes something very big smaller. So 1 centimeter of the drawing is 2 centimeters on the actual workpiece. Also, we have several different lines. So we have continuous lines, we have dashed lines, and we have long dashed dotted lines. And each and every line can be narrow or wide. There are not just rules for our lines, but also rules for the arrowheads. They have to be at a 15-degree angle, they have to be very thin, and they have to be fully blackened. What is the purpose of a technical drawing? It is a piece of communication, so it's the activity of conveying information. It is an official document. It is a representation of a person's thinking with symbolic marks. And these symbolic marks on a technical drawing are also following rules. These symbols are about surface quality, tolerances, or manufacturing processes, for example. So there is a symbol for milling, grinding, or polishing. These drawings are often very complex, but we want to communicate about them clearly, directly, and effectively. We want to avoid misinterpretation, and therefore there are strict rules. And these strict rules are all written down in the international industrial standards. A drawing has to meet or it has to fit the standards in order to be understood by each and every manufacturing or reading person. Geometric conditions. To align. Align means to arrange so as to be parallel, orthogonal, or intersecting. So something parallel is like this, something orthogonal is like this, and an intersection is something like this. Parallel means being everywhere equidistant and not intersecting. Orthogonal means meeting at right angles. So here we have a right angle, here, 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 here. But there are also several parallel edges. So this, and this edge are parallel to one another, and this, and this edge as well. A tangent is a line that touches a curve only at one point. So this is our tangent and is touching only in this point. An axis is a straight line through a body or figure, and symmetry means a balance among the parts of something. So on this drawing we have the axis right here in the middle, and a symmetry is established by the same dimensions and the same geometry on both sides. Dimensions are a construct distinguishing objects or individuals. There are 3 different ways to dimension your object, you can say. First up, fabrication ready, which means a machinist can produce this measurement without calculating. So on this drawing you see that this corner is a reference point, and from there on each and every measurement can be simply understood. So the machinist does not have to calculate how far things are apart. Next up is function ready. Each measurement has, according to its function, the highest tolerance. The tolerances are behind the actual measurements, so plus minus 0.1 in this case. And lastly, check ready. An inspector can check this measurement without calculation. So you see, an inspector works a bit different than a machinist. But reasons for this are very complex. So you have to keep in mind how a machinist works in order to make a technical drawing fabrication ready. You can do this with the help of chain dimensioning. So you see we have the complete length and all the different distances between the middle points of the holes, and you also have the entire height of the working piece next to the height of the middle point of the holes. When you use parallel dimensioning, which is more fabrication friendly, you always take one corner as a reference point, and from that on you take all your measurements. It also applies here. The running dimensioning is starting at one corner and it runs to the other corner. But here the machinist has to do some calculation. If he starts manufacturing here and he has drilled this hole, he has to calculate how far the distance is from this edge to this middle. And a staggered dimensioning starts in the middle and then it moves outwards. This is often used for round objects. A shape is a perceptual structure. We have a profile, which is an outline of something from one side. So from the front, from the back, from left or right, from above or from below. The outline is the line that appears to bound an object. The depth is the extent downward or backward or inward, and flat means having a surface without a slope or a surface which is level. So let's start with flat. Flat is, for example, this surface, this or this, and this one as well. The depth can be measured, for example, from here on to this point, to this, or this, or this. So here we have 4 different depths. But we can also talk about the outline. The outline matches with the profile in this case and is the white black line around the object. Round objects are, for example, a circle, which is a plane curve with every point equidistant from the center. Curved means having or marked by a curve or smoothly rounded bend. An arc is a continuous portion of a circle. The diameter is the length of a straight line through the center of a circle. Here we have the diameter and here we have the radius, which is just half the diameter. We see here a circle and here an arc with a certain angle, so in this case 90 degrees. But we can also have an ellipse, which is a closed plane curve with an oval shape. Cylindrical means having the form of a cylinder, and a cone is a shape with a circular base and slides tapering to a point. So here we have our circular base and the sides are tapering to one point, and then it is a cone. A cylinder has also round bases, but they are parallel to one another. So the sides are not tapering. Angles. The angle is the space between two lines or planes that intersect. So here we have our angle. And a slope is a surface which is at an angle. So here we have a surface with an angle of 18 degrees, or you can also tell it with the help of a ratio. So height to length, you can say. So this is, for example, 1 centimeter high, but 5 centimeter deep. 3D illustrations. There is the isometric scale, also called the isometric projection. It has two 30-degree angles to both sides. The edges are measured and drawn with 100%. The true scale, which most of us will know from school, has just one 45-degree angle, 100% length at the front and on the height, but the edges running backwards are just half the length they actually are. And the diametric scale, or the diametric projection, has two different angles. So we have a 7-degree angle and a 42-degree angle. The edges are just like the true scale with 100%, 100%, and 50%. Now we want to talk about sections. Sections are along a cutting plane. So first we want to cut along this plane. We receive a form like this. So let me show you. If we have a look at this rectangle, you can say that it is this piece. This part of the drawing is cut from here to here. And lastly, the triangle, which is here, is visible here. So if we flip the workpiece, and here you see this is not cut, but we want to cut it along the line BB, we receive a drawing like this. So these corners start here, go along the cut, and then they show how thick the workpiece is. We can therefore say that it runs like this, this, and this. We can also have local sections. They are for small areas which include more detail. They are defined by an irregular line which is often drawn by hand. So this line here. Details. Threads and chamfers have to be mentioned on their own because they are very important. So here we see chamfers, and these ones are 1.5 times 45 degree. The thread is made out of two parts, you can say. So here in the middle we have the full material, and the outer drawing here is the actual thread. Drilled holes and chamfers. So here we see a workpiece which has a drilled hole with the diameter of 35. And we have chamfers here and here, which have to be told by this. They have to be communicated like this. And the pointy bit down here is most probably 118 degrees, which is standard for drilled holes if there has to be a thread inserted afterwards. So this is the end for this session. Thank you for your attention and see you next session. Have a look at the additional material like the vocabulary list and make sure to take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with machine parts, so let's get started. First up, we will have to talk about some basic components. A fulcrum is the pivot point about which a lever turns. So, first up, I want to show you, here is our fulcrum. Next up, a gear, a toothed wheel that engages another toothed mechanism. So here we have a gear which is engaging with the worm wheel beneath here. I will write this down. A worm wheel. And a lever is a simple machine giving a mechanical advantage on a fulcrum. So here we have our fulcrums, and the long things attached are our levers. And to understand the definition a bit better, we can have a look at a very basic mechanical equation we often use. So moment equals force times lever length. So we see the more lever length we have, the less force we need to create a certain moment on a fulcrum. Next up, the pulley. A pulley is a wheel with a groove in it, which a rope can run. So we have a pulley made out of wood here, and in the 3 grooves there are 3 ropes running. A crank is a hand tool consisting of a rotating shaft with a parallel handle. So here we have the rotating shaft, and parallel to it we have our handle. The belt is a loop of flexible material between rotating shafts or pulleys. Here we have several belts which are applying force on this big wheel. And this big wheel is connected to the shaft here. Now we will talk about some fastenings. And a fastening is a device to keep something closed or tied to something else. Often used are screws. And a screw is a piece of metal with a raised edge twisting along its length and a shaped top. It is used to join things together. So here we have this raised edge twisting around, and we have a shaped top. So you can have, for example, a slit, or you can have a cross slit, and many other forms. And a nut is the counterpart for it. It's a small piece of metal with a thread in which you can screw a screw. So as they have done here, you can take this nut and then screw it onto the thread of the screw. Next up, the washer. A washer is a flat ring that is put between a screw or bolt and a surface, or between joint pipes in order to make a better connection between them and to protect the surface. So if you are using a washer to connect to pipes, you use it so the connection between the surfaces is better. And you also use a washer if you have drilled a hole which is bigger than it should have been. But then you can use a washer and screw the screw through the drilled hole without throwing the entire piece away. And a bolt is a metal bar that slides across to lock something. So our metal bar is this thingy here. A rivet is a metal pin used to fasten flat pieces of metal or other thick materials such as leather. So the rivets are these little points here. You can also often see them on bridges, for example. A thread insert is an element that is inserted into an object to add a threaded hole. For example, if you are restoring a very old car and you take out the engine and you have to work on the engine block, it is most likely that the threads in it are so old that they will fall apart the moment you loosen the screws. And then you can drill it out and you insert a thread insert. So there is a usable thread in it again. Now we want to talk about more complex machine parts like a power transmission or powertrain. So a powertrain is the machinery that brings the power produced by the machines, so produced by the engine, to other parts of the machinery, so the wheels. The powertrain of this locomotive is here. We can see that the engine is somewhere here. I have to admit that I'm not a professional for locomotives. And the power outcome is here. And you see several rods and beams, and they are transmitting the energy produced by the engine above here down to the wheels. And a bearing is essential for it, because it is a part of a machine that supports another part that turns around. So we can have a fixed bearing and a floating bearing, which means if we want to connect, for example, a wheel to an axle, we will most probably use a fixed bearing because it should not move. And if a bearing is fixed, the inner ring is not able to move apart from the outer ring. But if there is a floating bearing, this inner ring and this outer ring can move against each other up to a certain point. So if it is a very floating bearing, it can happen that if you flip the bearing, the inner ring will just fall apart. So you have to be a bit cautious about it. An axle is a bar connected to the center of a circular object, such as a wheel that allows to cause it to turn. For example, a car axle, or like here, a locomotive axle. So the bar connected to the center of the circular object would be this, and the circular object are simply wheels. A hub is the center part of a wheel or gear, and it is fastened to the axle or it is turning on it. So here you have the hub. And it is attached to this axle, and this should be a bicycle wheel. And the hub is essential because it is fixing the wheel to the axle so it cannot fall apart. A shaft is a rod of a machine that turns in order to pass power on to other objects. So here we have several shafts, like here, which are connecting several gears to one another, and they are transmitting energy. But a shaft is also a pole or a rod that forms the handle of a tool or a weapon. The difference between a shaft and the axle is simply that the axle is not transmitting power, but a shaft is transmitting power. So here the gears are often shrinked onto the shaft, while things on an axle should still be able to turn. Let's talk about engines. Engines are motors that convert energy into work or motion. Combustion is a reaction of a substance with oxygen to give heat and light. So a motor which converts energy into work does this with the help of combustion. So chemical energy from the fuel is via combustion converted into motion. A cylinder is a chamber within which a piston moves. The piston is the mechanical device that has a plunging or thrusting motion. So within the cylinder, the piston is moving up and down and up and down, and this is a plunging or thrusting motion. A connecting rod is a piece of cast iron which transfers the combustion energy from the combustion chamber via the piston down through the crankshaft. We will have a look at this in a moment. And the crankshaft is a shaft in a combustion engine which transfers the energy from the combustion in the gearbox via the clutch. Okay, so here we have an engine. If you want to, you can pause the video here and have a look for yourself, but I want to talk about it in a moment. Okay, so what do we see here? Let's start at this point. Here we have a bearing, a fixed bearing, I would guess. And here we have several threads. I would guess that here we can fix this engine to this shaft with the help of a hub. Next up are more bearings and a very special gearbox. Within this gearbox we can see several gears. We see some screw heads. Up here we see connecting rods to a piston within a cylinder. We also can see the clutch down here, and I think that this is the most important things we can see here, and I hope you now understand the vocabulary a bit better. Next up, the compression. An increase in the density of a material, for example, gas mixed with fuel. And a valve is a mechanical device for controlling the flow of a fluid or gas. So here we have a valve which is controlling the flow of fresh air, for example. And a spring is a piece of curved or bent metal that can be pressed into a smaller space but then returns to its usual shape. It stores potential energy, therefore. Here we have a spring, but we can also see fulcrums and a lever. Working with liquids or gases. If you are using liquids or gases, you will need a filter. And a filter is a device that removes something from what passes through it. So if you are filtering air, you want to get rid of all the hard materials which are sucked in the, while you're sucking in air as well. A flow rate is the amount of fluid that flows in a given time. Fuel is a substance that can be consumed to convert chemical into kinetic energy, so diesel for example. And a reservoir is a tank used to collecting and storing a liquid. A pipe is a tube inside which liquid or gas flows. And a hose is a long plastic or rubber pipe used to direct liquids. A leak is something, is a hole, a crack or a fissure through something enters or escapes. So if you have a leak in your hose or pipe, your liquid or fluid will be escaping, or it could also enter, but you do not want it. So a leak is something very bad. Wear and tear and safety. The factor of safety is the ratio of the breaking stress of a structure to the estimated maximum stress in ordinary use. So if the ordinary use of, for example, my cap here is that it just hangs here, this is the estimated maximum stress of ordinary use. But there's a factor of safety which allows me to pull on it a little bit and it won't break easily. And the ratio of the stress it is suggest to stand and the stress which could occur because something is applying more force to it is the factor of safety. And you always want a factor of safety to be above 1, because it is beneath 1. It means that the stress it is most probably to have to stand is too high, so it will break way before it should break. Fatigue is a weakened state caused by long stress on a material. So if I keep on doing this each and every day, this will it will experience fatigue and then it will break at a certain point. Reliability is the quality of being dependable. And the tensile strength is the strength of a material expressed as the greatest longitudinal stress it can bear without tearing apart. So if I have this pen and I apply some tensile strength, you see that it is not tearing apart, and this is the tensile strength. Now, I want you to pause the video and to apply some of the vocabulary you have just learned. So, here we see an engine, or we don't see inside the engine, but we see it from one side. So, what do we have here? We have belts, but we also have some gears. We have a pipe. We have a hose and a spring. We also have cables. Another thing we can see are the drive shaft. We can also see screws, for example here. And yeah, we can also see some rubber bearings. Yeah, I think these are the most important points. And I hope you have guessed at least some of them. And now I say thank you for your attention and see you next session. Have a look at the additional material, like the vocabulary list, and make sure to take the quiz. Bye! Hello and welcome to English for Engineers. This session deals with machines in more detail, so let's get started. First up, we want to talk about the lathe. This is a very old lathe, and you see it's a huge machine, and it is very complicated. Therefore, we will start firstly with this section, afterwards we will have a closer look on this section, and lastly we will have a look at just a section above. So, first up we want to talk about this huge trunk. Inside it we have the gearbox and the headstock. They are both inside here. The emergency switch is down here. It is always red and round. Then we have several charts for speed, gear and feed. They are important because different materials need different speeds, for example. Next up, we want to talk about the tools a bit more. So first is the chips pen. It is down here, and you can see there are already many long silvery chips inside of it. The saddle is here. The apron is this huge part down here, which is connected up here. The apron is maneuvered with the help of the apron hand wheel. The lead screw goes right through the apron. The cross-feed hand wheel is above here, and the micrometer hand wheel is up here. Let's talk about the hand wheels a bit more in detail. So, the apron hand wheel down here is working on the lead screw, so it moves the tool holder up here along this axis. So it starts here and it can move up to here. The cross-feed hand wheel up here moves the tool holder inside and outside, so it moves it in this and in this direction. And lastly, the small micrometer hand wheel is again maneuvering in the same direction as the apron hand wheel, so back and forth. if you are standing in front of a lathe, you turn the apron hand wheel so your tool will move from left to right. Your cross feed hand will move away and towards you, and the micrometer hand wheel will let the tool holder move again from left to right. Okay, next up, the dials. They are positioned on the hand wheels, like here. They help you to see how far you have already turned, so you can work very precisely. Levers are here and here, here and here. They are often used to fasten or to loose certain things on a lathe. Next up, we want to talk about these parts of the lathe in more detail. This and this is called the tailstock. The tailstock and the headstock build the ends of the lathe. The lathe bed is down here, and this is where the tailstock is moving on. The spindle or barrel is inside the tailstock, and with the help of this hand wheel you can move it out and in. The center is the pointy bit on the tailstock. A hose for cooling fluid is here. And a quick tool exchange is up here. It is called like this because you can very quickly exchange certain tools. So now we are looking at the other end of the lathe. Here we can see a huge chuck. Inside the chuck you can insert your workpiece. Here we have a 4-jaw chuck because we have 1, 2, 3, 4 jaws. But there are also different chucks. You can have, for example, a 3-jaw chuck. Jaw chuck. So then you would just have 3 of these. But you can also have a chuck which is closing from the outside to the inside. We will see such one on the next slide. And this chuck is connected to the headstock, which is inside the big trunk. So here we have on the left side a turning or a lathe tool, which is here, the gray one. It is made out of metal with an insert. So this little rhombus here is an insert. I will try to draw it a bit more so in detail, so you know what I'm talking about. So here we have our tool, and it got a pointy bit here, and inside this tool is a rhombus, and this is called an insert. Next to this, you also see some adjustment screws. Here, for example. We also see a workpiece out of copper in here. You can tell that it's copper because of the color. And we have a collet chuck. This one here. Collet chucks are very good if you have round material because they tighten from the outside to the inside, and the pressure they apply is on the entire circumference. But they often leave very nasty marks, so you have to pay attention how tight you screw them onto your workpiece. On the right side we see cooling fluid, which is this milky looking liquid here. And we see a huge drill bit. This drill bit is most probably inside the tailstock. And to make sure that the hole we are drilling is in the center of this workpiece, we use a dial gauge. And this dial gauge is measuring how centrical the workpiece is running. The milling machine is our next machine we want to talk about. Here we see a table with T-slots. These T-slots are important because they are used so we can screw a vise very tightly to it. The spindle is up here, and inside the spindle we insert our chuck, which is this part here, and our milling heads. We can also see the column back here and a machine vise. A machine vise is different from a bench vise because it can only be used inside a machine with T-slots, and also it is heavier and more sturdy than a bench vise. Up here we see many colorful chips. Now we want to have a closer look at this piece of a milling machine. First, we see the inserts. They are up here and they are the pieces that actually cut. The inserts are screwed onto the cutting head, and the cutting head is screwed onto the steep taper or the take-up shank. And the take-up shank is shoved into the spindle where they interlock, and then the rotating force which is moving the spindle is also rotating the cutting head. Now we want to talk about several different cutting heads. First up, the end mills. We have several here. This one, this one, this one, this one, and even this one. Next up, we also see one drill bit. You can distinguish between an end mill and a drill because of the pointy bit a drill has. So a drill always has a pointy bit like this, whilst an end mill is always flat. Next up is the thread cutter. We see it here. It is used for cutting threads. Now we want to have a look at several milling or cutter heads. They have indexable inserts. Indexable means you can remove them when they don't cut well anymore, or you can also exchange them if you want to cut them with a different geometry. So milling heads we see are here, here, and here. You can see all of them have a different geometry, and each of them can mill something different. So what do we have here? First up, we see a control panel back here. And inside this control panel is a DRO, and a DRO is a digital readout. You use these two to tell the milling machine where it has to go and where it has to cut, and how deep it has to cut, and also how fast. We can see an additional light source, so you can always check what you are doing. And again, we see a hose for cooling fluid. Lastly, we want to talk about some pumps. Here we see a turbocharger for fresh air on an engine from a car. But there are several other pumps. For example, like this one. This is a centrifugal pump. And centrifugal pumps always have a shaft in the middle, and they are always rotating, and whilst rotating they compress air or they transport liquids. Another kind of pump is the piston pump. And with this kind of pump, there is a piston moving inside a cylinder, and they are often used as air compressors. We have a suction side, which is here. So here we have suction, and we also have a pressure side, which is here. This suction and pressure is caused by the running wheel, also called the impeller. We have a pump casing, which is everything outside of the impeller. And we have a flange, which is here. And on the flange, we can screw the other half of the pump casing, so it is closed. Now we want to talk about this huge industrial pump. It is also a centrifugal pump, but it is a multi-stage pump. So here you can see that there are several pump casings, and therefore we have several stages, and therefore it's called multi-stage. Again, we have a suction side, which is here, and of course a pressure side, which is up here. We can also see that there is a pressure gauge to check whether there is too much pressure on the suction side. We have a pump casing, which is all the bright blue stuff on this side, so on the left. And we also see several flanges. Here is one, here, here, here. We also see on the right side the motor, which is powering this pump. And the pump and the motor are connected with the help of a shaft. The shaft is connected with the help of a clutch on the pump. We are already at the end of this session. I want to thank you for your attention, and I hope to see you on the next session. Have a look at the additional material, like the vocabulary list, and make sure to take the quiz. Bye! Hello and welcome to the outro. You successfully mastered this course, so now we are at the end. I want to congratulate that you have finished it. Now I want to give you some tips and advices for your future. First up, what can you do after this course to advance your English even more? I would recommend an oral coaching for better pronunciation, so your English will become even more natural and native speakers will understand you more easily. I could also recommend a course in business English, so your letter of application, your emails, or your letters in general will become up to point. I could also highly recommend to you some research about the cultural conventions for the country you are traveling to. This is important because if you don't know what the cultural conventions are, some uncomfy situations are most probably to come, and we don't want that. I also highly recommend literature in your area of expertise. This is important, so you would not just have quick access to some knowledge, but also to the vocabulary, which is important because vocabulary highly depends on the context. Some general advice from my side when it comes to speaking English. Keep it simple, keep it safe. This is an advice I used to pledge to all my students the entire time. It is important to keep in mind that you don't want to impress with your complex and sophisticated language, but you want to get your point across. And often it is helpful to keep your sentences as short and as easy as possible. As I've already mentioned, context is everything when it comes to vocabulary. Therefore, I really, really insist on researching your vocabulary as close as possible to your field of expertise. Words often have a different meaning in different contexts, and this could not just lead to misunderstandings, but it could also cause wrong outcomes. And therefore, I highly recommend literature or a technical dictionary which are close to your field of expertise. So the context is right, and therefore the vocabulary you will pick will suit best. So that's it. I have to say goodbye to you. I hope you enjoyed this course, and I really hope to see you in some future courses of ours. Bye!